It's May 1944. Germany has just been hammered by a devastating Allied bombing raid, and the Minister of Armaments, Albert Speer, goes to Adolf Hitler with a chilling realization. He lays it out plainly, saying, "It would be pointless to have tanks if we could not produce enough fuel." It's a striking paradox, right? Building this incredibly intimidating, technologically advanced arsenal, but completely lacking the lifeblood you actually need to run it.
Welcome to The Explainer. I am absolutely thrilled to have you here today because we are unraveling a historical puzzle that is just fascinating. We're going to look closely at this massive, dramatic contrast between Germany's formidable ground-level tactical might during World War II and its glaring macro-level strategic vulnerability. Okay, let's dive right into this.
Section 1. The German War Machine.
Now, before we look at how the wheels fell off, it's really crucial to grasp just how terrifyingly effective these weapons were on the ground. Take the Flammenwerfer 35. This wasn't just some standard piece of gear. It was insanely heavy, weighing in at nearly 36 kilograms. Used by highly specialized assault pioneers to clear enemy fortifications, this thing held about 11.8 liters of a terrifying petrol and tar mix they called Flamoil 19. That heavy, incredibly dense mixture gave it a massive 25-meter range for 10 seconds of continuous use. So even right down at the infantry level, you see this demand for immense energy and fuel resources.
And you can see that heavy engineering philosophy carrying over into their broader infantry tactics, especially with the MG42. Honestly, the MG42 is a brilliant example of engineering for mass destruction. The Germans realized their earlier machine gun, the MG34, had massive industrial bottlenecks. It just required way too much precise machining. So what did they do? They simplified the production without sacrificing even an ounce of battlefield effectiveness, putting out a weapon with a truly terrifying rate of fire. But, as we know, these weapons are only as good as the supply line supporting them. Moving on to Section 2, developing the Tiger tank.
Stepping up from infantry weapons to the absolute heavyweight of their tactical arsenal, take a look at the sheer mass revealed in this cutaway of the Tiger I. This was a 59 metric ton steel monster, and to protect it, they slapped on 100 millimeters of frontal armor. Just let that sink in for a second. Pushing 60 tons of steel and heavy weaponry across a muddy battlefield is an engineering marvel for sure, but it comes with a massive, massive physical cost.
What's really wild is looking at the competing design philosophies for this beast. Dr. Ferdinand Porsche developed this highly complex petrol-electric drive system. I mean, his design utilized dual 15-liter V10 engines just to power electric generators for the tracks. All that just to hit a top speed of 35 kilometers per hour. Meanwhile, the competing Krupp and Henschel design focused heavily on mounting that massive 8.8-centimeter flak gun and its turret.
But here's the catch. They ran into during early testing of the Porsche chassis. The underlying reality became totally inescapable. Driving a 59-ton steel monster requires an astronomical amount of energy. You can't just push it. It needs a constant, massive stream of fuel. And that, my friends, sets up the impending twist in our story.
Which brings us to Section 3, the fuel vulnerability. So, we've established that this mechanical war machine is virtually unstoppable in a tactical fight, but it is completely, utterly dependent on liquid fuel to move even a single inch. So the big question is, where exactly did they get this fuel? Well, Germany was incredibly vulnerable here. Their natural crude oil sources were highly limited. They relied mostly on imports from Romania and Hungary, plus a tiny bit of domestic production. Because of this severe bottleneck, they leaned heavily on synthetic fuel. They were literally converting coal into liquid fuel using the super complex Burgess hydrogenation and Fischer-Tropsch synthesis processes. They were essentially manufacturing their own lifeblood out of thin air. Or, well, coal.
All right, Section 4, targeting the oil industry. Zooming out to the macro strategy, the Allies looked at this complex synthetic fuel network and made a very calculated decision. They realized that targeting the refined fuels industry would entirely paralyze the German military. Let's track this timeline for the combined bomber offensive. It kicks off with the Casablanca Directive in January 1943, which laid the groundwork for a massive bomber offensive. By May 1944, the 8th Air Force starts intentionally targeting those synthetic fuel plants we just talked about. And by September 1944, Strategic Bombing Directive No. 1 officially makes oil the undisputed top priority target. It was a methodical, incredibly calculated shift in strategy.
And the execution of this strategy? Absolutely relentless. Bombers, like the B-24 Liberator, you see here, conducted massive runs over industrial facilities.
The 15th Air Force launched these totally devastating attacks on the Romanian Ploiești refineries. Thanks to these concentrated strikes, production there plummeted by an astonishing 44% in just a single month, April 1944.
You want to know how desperate the German High Command got? 350,000. That is the massive number of workers that Special Commissioner Edmund Galenberg had to mobilize by the fall of 1944. And their entire job? Just constantly rushing around to repair the bombed-out oil plants. It was a desperate game of cat and mouse. They'd fix these giant synthetic plants just for them to get bombed entirely out of commission a few weeks later.
And that leads us straight to Section 5, the collapse of production.
This is really the climax of our explainer today. Just look at the catastrophic plunge in German fuel production caused directly by Allied air power. The sheer scale of this drop is just staggering. In March 1944, Germany produced 181,000 tons of aviation gasoline. By January 1945, just 11,000 tons. The sustained bombing effectively wiped out the Luftwaffe's ability to fly. They had these highly advanced fighter planes just sitting on the runways, but they literally could not put them in the air.
And it wasn't just the planes. This collapse starved the ground forces just as severely. Look at this. Motor gasoline plunged from 134,000 tons down to 50,000. Diesel fuel fell from 100,000 tons to 64,000 tons. Remember those massive 59-ton Tiger tanks and the heavy infantry transports we were talking about earlier? Their mobility was being completely erased.
Visually, the core thesis just locks into place right here. On one side, we have an Allied bomber in action. On the other, the completely devastated Merseburg Luna synthetic oil plant. For the longest time, some historians argued that Germany lost its oil because Allied ground troops captured the territories. But the visual evidence and the hard production data prove otherwise. It was the sustained Allied air attacks from above that truly dismantled the industry, long before the ground forces ever arrived.
I want to leave you with a contrast that is just mind-blowing. The source material notes that by early 1945, the fuel situation was so incredibly dire that, quote, tanks and armored vehicles moved to the front by oxen. Every motor trip exceeding 60 miles had to be approved by a general officer. Just think about that for a second. The mighty 59-ton Tiger tank, an absolute engineering marvel, reduced to being pulled by farm animals because there wasn't a single drop of gasoline to spare.
It really forces us to look at military history through a totally different lens. You can design the most terrifying, heaviest weapons in the world, but as we've seen in this explainer, grand strategy and logistics will always dictate tactical success. Which leads me to this final thought to leave you with today. When building an unstoppable war machine, what good is the engine if you have no fuel? Thanks so much for joining me on this deep dive. See you next time.